Hello students, I have started the chapter Matter in Our Surroundings. I have given you the introduction, what is matter. So just a revision, matter is anything which occupies space and have mass. So in this chapter, as I told you, we are going to study the physical nature of matter. That is the properties, only the physical properties of matter. So the first thing is matter is made up of particles. So there were actually two group of scientists. One used to believe that matter is continuous, like a piece of wood, and the other group of scientists they used to think no, matter is in the particle form. So let us perform an activity to decide the nature of matter, whether it is made up of particles or not. So I have few things with me, like this salt and sugar. These are easily available at home. So I am going to take approximately 100 ml of water, and with the help of this marker I am going to mark the level of water. So up to this point I have taken water. Now we can add sugar or salt into this. I am going to add salt to this. This is very simple and all of us know salt dissolves in water with very little efforts. It's not very tough or difficult task. But have you ever thought where the salt goes? See, it's completely soluble in water. You cannot identify where is salt in this. Since like you drink cold drinks, nimbu pani, and in nimbu pani itself, it is actually made up of water, sugar, salt, nimbu. So where it goes? It looks uniform. You cannot make out this is sugar component, okay, this is lemon, or this is salt or water. So it looks uniform, see. So have you ever thought where it goes? So this activity shows that matter has space in between. So in this case, the salt goes inside the space in between the water particles. So it dissolves completely. So when we dissolve salt in water, the particles of salt, they are inside the particles of water molecule. Now next point is, we cannot see the matter actually with the help of our eyes, naked eyes. So how small are particles of matter? Let us perform one more simple activity to understand this. How small are they? So for this, again I am going to take some water. Now I am going to add a drop of ink into this. 1 or 2 drops of ink is enough. See, like you play Holi with colors. So a single drop of color is sufficient to make the water colorful. It mixes immediately. Now I'm going to dilute it. I have taken little amount of water. Add this water, colored water, into the simple water. Again dilute it. And we can further dilute it. But I think this is sufficient to understand. See the color in the first glass. It is very dark. And on diluting, the color fades. On further dilution, color fades. But still, color is there. So, this shows that particles of matter are actually very, very small. If I will dilute it further, there will be faint color. So this shows that particles of matter are very, very small. Even a single drop of color is sufficient to make approximately 1 liter of water colored. Correct? So particles of matter are very, very small, and this is beyond our imagination. So the second point, how small are particles of matter? They are very, very small. So these two properties I have explained you with the help of these two simple activities, that particle of matter, they have a space in between them. Second point, they are very, very small. And now come to the characteristics of particles of matter. What are the characteristics of particles of matter? So the first point is, particles of matter have space between them. So particles of matter, they get into the space, and this shows there is enough space between particles of matter. Second point, particles of matter are continuously moving. This we cannot see, but this also you can understand with the help of a simple activity, like all of you must have seen boiling water in your kitchen while making tea or other activity. So what is that? That means they are moving. So why they are moving? Because on heating, the kinetic energy increases. As the temperature rises, the kinetic energy rises. And there will be a point, if you will keep the water boiling, they will go out of the container. They will evaporate. Right? So on heating, the kinetic energy of the particles increases. Now, this you can perform a simple activity, like take hot water and in another glass take cold water. Try to dissolve the sugar in both the glasses, in hot water and in the cold water. So you will find that it is very easy to dissolve the sugar in hot water compared to the cold water. So why this happens? Why this is so? Because when the liquid is hot, its kinetic energy is more. And the meaning of kinetic energy is particles are colliding with each other at a higher speed. That's why with the increase in temperature, kinetic energy increases and the solubility also increases. So it's easier to dissolve the solid things into the hot water. So the conclusion is, particles of matter are continuously moving. They are not fixed at one place. Now the conclusion, particles of matter, actually they intermix on their own. See, like in this case, it was so easy to dissolve the ink in the water. Without shaking, they can mix into each other. And if you, your mother is cooking food in the kitchen, when it is hot, you can make out sitting in the other room. Okay, so my mother is cooking something. Why? And compare the cold food which is there in the kitchen. Can you make out something is there in the kitchen without going inside? No. Why? Because when food is hot, the vapors are coming out of it, their kinetic energy is more and they can diffuse into the air. So the mixing of particles on their own is called diffusion. Okay, and in case of diffusion, particles move from higher concentration to the lower concentration. Meaning of concentration, that means where the food is being cooked, vapors are more, they are going out and they automatically reach to you in other room. So you can make out, okay, the food is being cooked in the kitchen. So this is called diffusion. Mixing of particles on their own is called diffusion. Now on when the temperature is high, diffusion is more. Temperature is low, that means kinetic energy is low, diffusion is less. Now next point is particles of matter, they attract each other. So something is there. See, look at this sugar. You cannot change it. It will remain like solid sugar. When you dissolve it in water, it mixes. Where it goes? Again it goes into the space in between the water particles. So something is there which binds them together. Like I have iron nail, simple iron nail. Can you break it? No. It's very difficult to break this with the help of simple hands or by hammering also. No, you cannot break it easily. Now I have chalk with me. This is also solid, but you can break it easily. Now I have rubber band also. You can stretch it. This is also solid, but you can stretch it easily. So what is the difference between iron nail, between chalk and this rubber band? They all are solid, but there is force of attraction which is different in all three. In case of solid, the force of attraction is maximum. In case of this chalk, which is so easy to break, the force of attraction is lesser, while in case of rubber band, it is very less.